अस्सलाम वालेकुम। आप लोगों को हमारा कल एक इवेंट हुआ था टेक टॉक्स 1 का, सैटरडे 24 को। तो आई होप कि आप लोगों को वो इवेंट अच्छा लगा हो, जिसमें हमने डायरेक्टर माइक्रोसॉफ्ट ब्रांड स्टूडेंट एम्बेसडर को इनवाइट किया था। उसकी जो रिकॉर्डिंग है वो इंशाल्लाह हम लोग मंडे को अराउंड 9 PM जो है फेसबुक पे वॉच पार्टी पे हम लगा के शेयर कर देंगे। तो या तो आप वहाँ पे वैसे देख सकते हैं या आप बाद में देख सकते हैं। इंट्रोडक्शन टू क्लाउड कंप्यूट, ये हमारा सेशन है इंट्रोडक्शन टू क्लाउड मशीन लर्निंग यूजिंग अजूर सर्विसेज। इसमें जो है हमने जुनैद इकबाल को इनवाइट किया है, जिनका काफ़ी एक्सपीरियंस है एआई में। फिर क्लाउड कंप्यूटिंग में भी वो अराउंड 30+ सेशंस करा चुके हैं, और वो फाउंडर ऑफ एआई स्कूल यूनिवर्सिटी ऑफ लाहौर भी हैं, प्लस प्रेसिडेंट ऑफ माइक्रोसॉफ्ट स्टूडेंट एम्बेसडर लाहौर भी हैं। तो ये हम इवेंट जो है रिकॉर्ड कर रहे हैं, और इंशाल्लाह ये भी आपको अराउंड सैटरडे या संडे तक, क्या हो सकता है वीकडे में भी हम, डिपेंडिंग के क्या रिस्पॉन्स में आता है, हम पोल कर लेंगे और साथ से हम इसको अपलोड कर देंगे। तो इसके एंड में एक क्विज़ भी होगा, वो आप लोगों ने अटेम्प्ट करना है। उसकी डेडलाइन सेट हुई होगी 24 आवर्स की। उसके बाद जो है हम विनर्स को ई सर्टिफिकेट्स ईमेल करेंगे। तो अब मैं जुनैद इकबाल को बुलाना चाहूँगा कि वो सेशन अपना स्टार्ट करें।
Hello everyone. Uh, can you hear my voice clearly, Adil?
हाँ, आपकी आवाज़ क्लियर है।
Okay, perfect. Okay, I'm Muhammad Junaid Iqbal, Senior MLSA Beta at Microsoft, founder of AI School and .NET developer with having 1.7 years experiences at LOXVO Technologies, Lahore. And I'm a ML facilitator, top technical writer at Quora. Contact with me at junaidikbal.com. So now we begin our session, getting started with Azure Machine Learning. So, what is Azure Machine Learning? So, actually, we'll begin with the scratch. So, what is Azure Machine Learning? Azure Machine Learning is a fully managed service that you can use to create, test, operate, and manage predictive analytics solutions in the cloud. With only a browser, you can sign in, upload data, and immediately start machine learning experiments. It is just drag and drop predictive modeling. A large palette of models, modules, and a library of starting templates makes common machine learning tasks simple and quick. So, it is also called Azure ML for short. It is a data mining, data science, and machine learning tool in the cloud. But it's different than most data science tools because there is no coding involved. Traditionally, data science tools involve Python, MATLAB, R, or SAS. Which is all coding based. So you had a terminal, and you had a command line, and you had a learn syntax. Note this one. This one is a drag and drop approach to machine learning. So it has a visual interface, and it feels more like Visio or PowerPoint than it does any other traditional data science tool. And I think this is the best tool for learning, machine learning, and data mining, because you don't have a juggle both the syntax of learning how to program at the same time, and juggle how to data mine at the data mining theory. So the data mining frameworks and also the theories of machine learning in general. But this is not just a tool for beginners. Advanced users also will love this as well, because it does a seamless integration with SQL, R, or Python, and you can mix and match. So all of a sudden you can be using SQL, drop SQL using a user module, and all of the sudden switch and switch again and again, then go into R or Python. I do at all the time, and also you can deploy these models, machine learning models automatically, meaning basically they pick up your model, throw it into a cloud somewhere, and then you can contact those models via REST APIs, and then you can connect those APIs using your auto-generated code using C Sharp, Python, R, or MATLAB. As your machine learning Azure Machine Learning is a cloud-based machine learning tool that only exists in the cloud. Specifically, it is on the cloud Azure stack, or so the Azure cloud platform. And Azure is one of the services within the Azure ecosystem itself. So Azure is the cloud platform brought to you by Microsoft, so that makes Azure ML by extension a Microsoft technology. Azure is also comparable to other cloud services like Amazon Web Services, AWS, and Google Cloud Services, all of which are infrastructure as a services, meaning they are a platform that can host a robust IT services that can build entire software platforms. Like Netflix is also on, as you know, on AWS, or Snapchat is on GCS, Google Cloud Services. These cloud services are all software as a services, where you use these services and they charge you by usage, like an electric bill or a subscription services like a cable bill. Because Azure Machine Learning Studio is a cloud-based tool, it brings it the strengths and weakness of cloud computing itself. So let's learn the pros and cons of cloud computing. So so that you know what you are getting yourself into. So the first thing is the none of the cloud services will almost ever ask you how much data you need to store. They would just store and not ask any question about that, and the reason for that is storage space, especially on cloud. Azure Cloud has been plummeting pretty consistently every year. It's gotten to the point where it's only going to cost you about $0.02 to store anything online per gigabyte per month. So it doesn't matter if you are on AWS or any other GCS or on Azure, they will both charge you about $0.02 per gigabyte per month to store something, which is also a most informative information about subscription as zero point zero 0.02 per gigabyte app per month. So which is really cool because it basically removes data size as an equation when you have to deal with your capacity with your machine learning tools and hardware. So the next thing is machine learning does not exist in a vacuum. Machine learning is extremely dependent on large data sets, like big data is dependent. Big data is dependent on IT infrastructure. So the IT infrastructure, in order to have an IT infrastructure big enough to support big data, you have to have either some kind of robust services like data warehouses, or you can rent that stuff from AWS or Google Cloud, Azure, one of the cloud services. As you know, Alibaba is newly coming in the market, one of the cloud service. So specifically in Azure, you have all of that data infrastructure to back up your machine learning. So you have, for example, Azure SQL databases as your database. You have Spark and Apache Hadoop in the form of HD Insight. You have blob storage, data lake storage, stream analytics in the form of ATL, and Azure Data Factory in the form of in your all data pipelines. And more importantly, because it's a Microsoft technology, and it integrates with Excel, Office 365, which is one of the most common used BI tools in existence. So the next thing I find that's really cool is that it runs on someone else's machine. That doesn't sound like it means much, but the idea is you need you don't need a very powerful computer anymore. You don't need a workstation desktop anymore. What this means is you can get an iPad or use any of these cloud-based tools, hit the run button or the execution button. We will also do some practice on after this presentation. Uh, and If the device can open up a browser like Chrome, Opera at a start, the idea is it can run the cloud service because it's in the cloud. It's also collaborative, which means you can invite other people, your cloud spaces, and work together and share the same cloud space. Another thing, it's scalable. So the cloud is very good at distributing workloads. As you know, among many multiple nodes, multiple surveys, calling upon extra help when it needs more processing power or more storage. So let's go over the cons of cloud computing by using our cloud-based tool. You are committing to an unwavering internet connection. You can never lose internet, or because as you know, cloud, every cloud, Azure, AWS, and GCS, to us a same demand to do every cloud a simple internet connectivity. Can you even in the cloud is what the that thing is trying to ask. Does your industry, does the government that oversees your industry, does your company, or do all those policies comply, is such that your data can be in the cloud? This is all about data governance. So there are two main ways to get Azure Machine Learning Studio. The first is the free trial method, and the second is full workspace method or pay. It's paid. So to get a free trial Azure ML workspace, what you do is you just simply go to Azure Machine Learning website, azure.mlstudio.com, sign in with your email, and you will be given limited access workspace. If you want to fully working workspace, then you will need an actual Azure subscription. Then once you are inside of that subscription, go ahead and you will have to create an Azure ML workspace within that subscription. This is the full workspace. Now, if you have never used Azure before, then Azure will give you a free trial subscription to start off. So you will get a $200 credit on your Azure subscription, or 30 days, whichever limit is reached first. Now, if you have used up your Azure free trial subscription because you have used Azure before, then you will simply need to go the pay as you go route, where you will add your credit card or to an auto pay system, and it will charge you for the fee that you have incurred based upon just cloud users for the month. So there's really two part or to the pricing of Azure Machine Learning Studio. First is monthly subscription. Second is for users. So first is the subscription. You have charged for $9.99 per month per seat. So for each workspace, you will be charged about $10 a month. Secondly is your charge for usage. Depend on your usage on Azure Machine Learning Studio. So there are three parts or to the usage. The first one is runtime. So your charge $1 per hour of experiment runtime. So every runtime you hit the run button on your experiment, you can check on this image. That is what you are being charged for. The second part is you have charge for deployment calls. So anytime anyone calls your deployed web services, basically your REST APIs, for every 1000 API calls, you are charged about $0.10 to $0.50, depending which tile you are going with for your web services. Now, the first 1000 API calls are basically always free. So unless you are an e-commerce business, I don't foresee you actually getting it with these charges so at all for deployment. And then the third usage, if you are charged for storage of data, if you are more storage, like if you are using more SQL data, SQL and any other databases. So basically, whatever data you pull into Azure Machine Learning, as we also seen in during practice level, and then so Azure services we are going to use. So Azure block storage charges $0.02 per gigabyte per month. It is actually less than $0.02, but they are going around it up. So it's going to be about $0.02, and then if you are going as you go
जुनैद आपकी आवाज़ कट गई थी,
now.
आप रिपीट कर दो थोड़ा सा ना.
Okay. So I'll just discuss you Azure Blob Storage. If you are using Azure Blob Storage on Azure Machine Learning, which is the services we are going to use to Azure Blob Storage charges zero point zero 0.02 per gigabyte per month. So it's actually less than $0.02, but they are going around it up. So it's going to be about 0.02, and then you are going to with the whole pay as you go for this web series. This web will probably cost you $20 for the month. So $10 for the seat and another $10 for usage. So these all about subscriptions and experiment runtime. So as you see in the screen, experiment runtime is on your screen at runtime. It's runtime about your pricing or depend on your subscription. So I will use pay as you go services, or my subscription is beta MLSA. So just a minute. Okay. So Adil, my screen is visible.
Just a second. Yeah. Yes, now it's visible.
Visible or not?
Yes, it's visible.
Okay. So this is a Microsoft Azure homepage. I will not discuss you about Azure and cloud computing. I think Tech Talks have also arranged cloud computing years how to start Azure. So I will just give a session on machine learning studio or Azure machine learning. So I will start it from scratch. So search resource or services, machine learning workspace, machine learning studio workspace. So click on add button. Okay, so give just a minute. Okay, so give your unique workspace name if you have multiple workspace. I'll just MLC Microsoft Learn Community Karachi KHI. MLC KHI, my workspace name, resource group. I have new created MLC KHI, MLC KHI. Okay. So, okay. Workspace pricing tier. I have just tell you about what are pricing tier. So I by default it is select standard. So yeah, so web service plan, MLC Karachi plan by automatic by default. So web services plan tiering if you pricing selected standard or any other. Just a minute. Okay, dev test for we'll just use dev test or standard S1. If you are using a dev test, it is free of cost and 1000 transactions you are using and 2 compute per hours. Scaling is manual, and S1 is standard, 25 compute hours around 1 lakh transactions and manual scaling, and S2 other and standard S3. So we are using S1 standard. Okay, create. It will just create some minute a while, so 1 or 2 minutes. So it is submitting deployment. We are going to create an Azure Machine Learning workspace within that subscription. My subscription is Beta Microsoft Learn Student Ambassador, and you are using whatever you subscription use, pay as you go or student offer. We are going go in and explore the features within that Azure Machine Learning workspace. So the first thing we are going to need to do is we are going to need to get an Azure free trial subscription. And the first thing you can do is you can either type in this link. The link is Azure Machine Learning, or you can search it on your Google or Bing, Azure Machine Learning. Okay, Azure Machine Learning Studio. Okay, studio.azureml.net. Okay, so goes to sign in, and if you are not sign in, so just use any Azure public succeeded. Refresh. MLC Karachi. Okay. Okay, so it is paid, and we are using standard pricing tier. Uh, Drag and drop machine learning workflows, build and deploy solution, leverage the community, and view. Click on View Machine Learning Studio. If you are using this, subscription, just a minute. Okay. My experiment. Okay, so just a minute. Don't see, no. Okay, so so the first thing you can do is you can either type in this link in the web services plan pricing tab, picking what kind of tier of services you want to that web services. So there are too many region, South Central US and Southeast Asia and whatever you are using. So there are three workspaces you can see: MLC Karachi, Muhammad Junaid, Muhammad Iqbal dash free workspace. So if you are using free web space, you have limited to access of runtime, and other is Fireside. So we are create a workspace MLC Karachi. Click on MLC Karachi. So I would switch the workspace MLC Karachi. Remember, you are charged as I already told you, $9.99 per workspace. So I will use $9.99 per workspace. So keep that in mind. So the data sets that you are being into Azure Machine Learning will be saved here. Uh, so I discuss you about what is modules and how to create experiment on this studio. So just a minute. Okay, so you can see this screen and a project. If you are using, if you are created other projects, if you are this is the this is new the project. This is new machine learning studio subscription I have created. If you are so first I'll discuss you about Azure Machine Learning Studio dashboard experiment. If you are using a click experiment sample, there are so many other samples on experiments, UCI and other data sets and cross validations and many others as experiments by default. Machine Learning Studio will give you. So just a minute. So okay, to create a new basically experiment, so or a new anything, you can go to this new button uh, and on the button left hand corner of your screen. So click on this new button, and so we can create a new and then blank experiment. So click on blank experiment. So now so new just a minute. Okay, so if you needed any help on learning how to do something like, I don't know, preventing maintenance, you can go ahead and clone one of those things. You can use this experiment tutorial and many other learning material, and you can also use Microsoft Learn site for machine learning and many other if you want to learn. I'm going to go ahead and close this box right up here. So this is our experiment workspace, and notice it gives us some hints as to how this works, and notice that it operates by some kind of module connecting other modules in some kind of workflow type fashion. And if you have ever used Visual before, it looks like a Visual that only flows from top to bottom. That will be your control panel. And you can expand it left and right over here. And let's take a look at our saved data sets, real save data sets, and go to sample. There are many samples you can see. Adult census, incomes post, we can drag and drop adult income spends, income binary. uh, so, and I'm going to drag in the adult census income data set. So notice that all I had was just drag it in. So clicked, held onto it and moved it onto the workspace, and notice that this object is representing the entirely of data set. Or I can visualize the data set. Just a minute. I can visualize the data set that is the object is representing an entirely of the data, or I can visualize that. For the most part, you want to visualize the data set. So notice that I can right click and visualize. So this will give you a window that will show me the first 100. I think first 100, yeah, first yeah, 15 columns and 32,561 rows. So this is just a real simple snapshot of the data, and I think this is the first 100, I think, column of the data set, even though there's not 100 columns. So this is a data set we can see about the census and demographic information about various. So each row represents a person. These each row. I can so notice if I can just click on any column, I can get very light descriptive stats of the data in this column. I can also convert this data object to CSV file or comma separated files wherein I can then feed that into SQL database. Just a minute. Okay. You can click on data format conversion, convert to ARFF, convert to CSV. If you convert this data set into CSV file, you can just drag and drop, convert to CSV, and click on run. When I just tell you about had 1,000 run time, so this is first run time. You can see finished run. This is first run time. So I will in this subscription I have used 1 lakh run time. So convert CSV or just a minute. Okay. So you can download it because this file is converted in CSV file. You can feed that into a SQL database or open it in Excel or Notepad or something like that. All I had was took this, held it down from the output node and drag it into input node of this. So notice that the top node is always the input node, so data is going in, and notice that there is data going out of this as well. So it goes in some kind of function or operation happens in here. So this is operation just has to be converting to CSV file, comma separated values. It is open in Excel. So I will when I will click on run, so you can download, click on download. It will download in Excel sheet, CS or CSV file. You can see this experiment created and download. So this is all about just data formation, format conversion. You can convert it any format. So if I want to export data, this is the main thing. Export data, export because if you have a data, if you have a launch a website or application on Azure machine learning web apps, you are using web app services or any other services, Android, iOS application launch on Azure. When you are using web services, so you can use this Azure machine learning, predict anything, house predict or any other thing, rents or any real-time problems on your web service, on your website or application. So you can use export or import or input output data. So you can use this just a minute. So you can use this data input and output. So export data and import data, if you are using export data, you can export any of format. Just a minute. Okay. So when I click export data, up some sidebar right on right side will be have occurred. So you can see this Azure Blob Storage, Hive Query, Azure SQL database, mostly used SQL database. Or if you have a website or you are using SQL database on Azure, so you can export this data on your SQL data, because if you are using if you predict on predict anything on your website, if you publish and on application Android, iOS, etc. So your database is on SQL, you are using SQL database, so you can export it. So you can export it SQL database, Hive Query, Azure Table, and Azure Blob Storage. So so you can just give your database server name, database name, and some information. So you can export it when you run this Azure Machine Learning Studio. So this is all about export data, delete it, and you can. Another thing is import data. Import, you can use import. You can import and import data from your website or SQL data from your site. You can use this. Just a minute. You can use this and launch import dataset. Click on launch import dataset. You can see this web URL or HTTP Hive Query Azure SQL because many of students and companies and industries like level and everyone know about Azure SQL database. So click on Azure SQL database, and next is subscription ID. Give subscription ID and database server name, then database name and username password. So your connection is creating with Azure Machine Learning Studio. So I will not discuss you about what is Azure SQL. I just tell you about how to import data from your web and app services. So these some information all about some basic information of Azure Machine Learning Studio. So we move towards machine learning, our model, and joining, how to join and create a model. So okay. Okay, so we'll take a data set and bring it into a predictive model. Have some data set like okay, just a minute. So we will take a data set and bring it into a predictive model and then deploy that model. So okay, so to begin, we are going to start a brand new project. You can save, or you can also save this project. And the data set that we are going to be working with is under samples, and there is a data set down called the flight on time performance. Just a minute, flight. Our data set. So if you go ahead and visualize, I think it's data from 2011. I think 2011. Yeah, so it's data from 2011, and it's basically can we use this data, can we use the past to predict the future, and the past being each row in this data set refers to a flight, and then each column is an attribute like a year, quarter, month, day of week, and many other columns, 18 columns in this data. Is the arrival delay, um, okay, arrival bulk, arrival delay, arrival, yeah. So is the arrival delay, can we behind by 15 minutes, yes or no? If there is a one here, it means just it means that it was delayed more than 15 minutes. It will. So then it's zero here. So it gets called arrival delay del 15. So arrival delay is at 15, and this commonly is actually basically what I think it's based off this column right here, which is by how many minutes was the flight on time or delayed, or early. All right. So it was arrival delay. It was first column is a minus 6, negative 6 arrival delay. So it means the flight was 6 minutes early. The flight, actually I will just tell you about data. If you didn't know about what is the data, and what is the information in our data, you didn't create your model, or perfect create your model, or not perform any machine learning task. So firstly, we mainly focus on our data. So I will just explain how to how to understand data. So the flight was so the flight was a 6 minute delay. So the next is 12-minute delay, and 14-minute delay, and the fourth is 6-minute delay. So if a number is here is greater than 15, drop. So drop a column. So if in quarter, I will also go ahead and drop this column. If the information is not useful, like year, quarter, month, day of week, carrier, these information not useful for us, because there are 18 columns. If you are if you less column you can use, and you can predict a best model on machine learning. So I will just open notepad to explain which column you can drop or which column you are cast category. And so the first is year. First year can drop. Okay. Quarter you can drop. Okay, so as far as the month is concerned, let's take a look at month. Month looks like it is under the same thing. Month is also drop. So whoever queried this data created all in the same month, in the same year, and in the same quarter. So we are going to build a predictive model that's only going to be good for October, like October. So so with flights, it's very seasonal. So if I would imagine that you would okay. Uh, so day of the month being what day is it? Is it October? I through 30, 1 through 30. So the problem with the day of month also drop. Day of month drop. Okay. Is that I am going to use this feature to build a predictive model. It's not going to be very useful because I am going to predict the future. What happens on October, like today is I think 23, might be on different day. It might be Sunday or Monday instead of Thursday, Friday, or it might land on a different holiday or something like that. So this feature it's too granular. So to this particular entry, it is good historical information because I can use this feature to basically determine is it a holiday or not, or what day of the week it is. Sunday, Monday, Tuesday, anything. But it looks like someone already did that for us in here over here. What is day for the week, which is here are 7 unique values here, Sunday to Saturday. So that tells me this is Sunday through Saturday. For now, let's drop it. So I am not saying it's not useful. I am saying in its current form, we are not going to be able to do much with it. So we don't want the model learning. Okay, so if it's October 23, I think today is 23. In every time in the future, it's going to. I think it's today is 25 October. So no, that's not how it works, because the way the calendar works, it's going to keep shifting days of the week and things like that. So day of the month I'm going to ahead and drop. But also note that it might be useful to find out holiday can drive holiday. All right. So and there is day of the week. So day of the week, day of the week is all about Monday through Saturday. We don't know what lines up with what does 4 mean, or is a 4 Wednesday, or a 4 is Thursday, like 444. It depends where day of the week lines up. So we have to go do some domain research and basically look up what October 2025 is and what day was it back in 2011 or 2020 of October 25, and then we can figure out what this day is. We will do that later. So day of week, and we want to do that because if we want a feature later that says a weekend is not weekend, that would become very useful for us. All right. Day of the week, it's going to be useful, and right now it is casted as numeric column. I would say it is not numeric, it is actually categorical. Remember, categorical is distinct bins or buckets of thing that could have a bin. Numeric assumes that there is something something like a kind of progression between 1 and 7, even though yes, you are processing through time, but the jump between 7 and 1, it doesn't make sense because it's a cylindrical loop, and this data set currently doesn't encompass that. So we have to cast this into a category. So okay, so we have to cast this into category because it's a numeric right now. Day of week. Day of week. Day of week is a cast category. CATEGORY. So okay, so for example, if yeah, I can just imagine that if you had anything to do with Lahore's Alam Iqbal airport, and then you would probably be late, or Karachi airport, or one of those really busy hub airport, or so yes, let's include this, but also include because they are codes right now, and it's also treating as numeric feature. So other a carrier, CAII carrier, cast category, and origin airport ID, cast category, cast category, and destination airport cast category. Okay, CRS depth time, CRS depth time drop, and CRS depth time, bulk depth time. Okay, I'll just tell you I didn't write it. So CRS bulk time is also dropped. Depth delay, departure delay, keep, and it is numeric data. The departure delay 15 is also a category. We didn't drop it. CRS arrival time, we will drop it, and arrival time bulk is cost category. It is cost. I will so we are not drop it. Arrival delay. Arrival delay is the main data response class, so it means response class. We for time being we will just drop it. And cancel arrival 15 is not drop it, and cancelled we are just drop it, and diverted is also response class, and we also drop it. So but for now we are only going to predict arrival delay by 15, arrival delay 15 000. So this is going to be our response class, and this is also need to be cast into categories. So this is basically our attack strategy. What are going to do as far as data manipulation and transformation. So these all about discuss about data handling, how to deal with data. Okay. So now we will pick another data, flight delays data, just a minute. Okay. Course data, because okay, just a minute. Okay, now I will told you about how to rename column columns. Renaming column is a very mundane but necessary task in data science. These are some of the scenarios that might make it necessary to rename columns. So let's say you have read in a data set. I will just make some already implement a machine learning model for you guys. The first is airport codes data set. So you can just drop it, airport codes dataset. Okay, I will just visualize this. So someone gave you a bad column name. No, you need to rename. It just have four columns. It's useful information for to train our model: airport ID, city, state, and name. Because we are renaming this by default. You can see this airport dataset visualize. Uh, so uh, Airport ID, city, state, name. So okay, if you rename your data because it just so happened that there is another table inside of Azure Machine Learning. So if you look at sample data set called airport codes data set, if you are drag it in your experiment, these are airport IDs. I just visualize, click on visualize. So there are airport IDs. So the idea is if we can cross reference these IDs and airport IDs from actual flight table, so to this table we can actually then get what state did the flight departure from, what city did you flight departure from like Lahore or Karachi or Islamabad. So and also what is the name of that airport, what actually might be more clearly than airport ID. So we are going to do join on this table later, but before we do that, through something is going to cause that to be a little bit wide, because we actually need to do this join twice, right? So because there is an airport ID for destination and there is airport ID for origin. So all right, we are going to have to make that join twice. uh, okay, click on so just edit edit metadata. So drop it, drag and drop, and okay. So first edit metadata when you join this from Azure airport codes dataset. Edit metadata, you click on launch column selector. You just click three select column: city, state, and name, because airport ID is our unique to connect with origin, airport ID from origin to destination. So so the new column is origin city, origin state, and origin airport. So my dataset columns name is city, state, and name, but we didn't understand what city is, like Adak Island, Antioch, and Barrow. I didn't know about what city is. It's origin city or destination city. I didn't know. So we will create a metadata. So renaming our data. So if we click this visualize, click on visualize. So you can see this origin city, origin state, and origin airport. We are renaming this as you can see this origin city, origin state, and the destination city, destination, because destination city, state, and destination, because this data is destination for destination use. First origin and the other is. So we okay, you can see that we can launch what's called a column selector. So these are the column selector. So these are the column that we want to make the changes to the. So and notice that every bottom there is a section called new column names. The new column names accepts basically a list of new column names to be overwritten. Same as for destination. Okay. So the next step is to join data. So our main data set is flight on time performance. You can be because I have already told you the briefly explain the flight on performance data, explain and what columns do I drop and what columns do I cast study and what columns do I what columns are responsive class. So we just drop it and just a minute. Okay, so so if I open up the sample data file, so I will go ahead and find the flight on time performance and just click on flight and time performance, flight and time performance, and drop it. So if we visualize, right click and visualize on the output nodes, we can see that airport ID will be the unique identifier. Okay, I can just visualize this, and if we go into flight on time performance and visualize this, you will see that there are two columns that are using these airport IDs. This is the airport ID. Yeah, so origin airport ID. These are the unique our unique our data. So we will so when we combine these two data sets to this selection table, we will end up with at least 3 additional columns per join. So this is going to add a 1 2 3 or is going to add 1 2 3 or so. This is hopefully improve the quality that our machine learning model can learn from later. So it's always going we just deal with our data first. We create best data. We can visualize, we can understand what the data is and what data we will do train and what data we drop and in cast category. So you will have a module called join data. So you can see this join data. So we'll just join first our data flight on time performance with first because we join all the data, then we drop columns, and then the next step is drop columns. So before drop your columns, what the information, because we need we need just informative data. We didn't know, we didn't allow the data to train for data to train our model like year and week, months. We didn't concern with these data. So first we join these two data, and then this joint data will join from rename rename destination data and from this data. You can see this if you visualize this. You can see this. You can see this. Just a minute. Okay, so visualize this. All we combine this data, joint data, all our column, all the columns. So 26 columns, 18 plus I think 4, 18 plus 4, 18 plus 4. 18 plus 8 I think yeah no sorry 18 plus 8 18 columns, 4 columns is this in this data, 18 columns in this data, 4 columns in this and 4 columns in this. So total our columns is 26. So so you can see just a minute. So you can see this all the data, all our data, origin airport ID, origin city, origin state and origin airport, and the other column origin airport ID to destination city, destination state and origin city. So now we drop all the columns we will which we don't need for our model, like year, quarter, month, day of week, carrier, and CRS departure time, deep time bulk, and CRS arrival time bulk. So these information are didn't we didn't concern with these information. So we will drop this. We will drop by using column in dataset, because we just select those columns which we need. So click on this launch column selector. So you can see, you can imagine, all the Microsoft Azure Machine Learning Studio is just click and just drag and drop and click, and you create a model. So available month, day of month are those who which we don't need for predict our models. Information, our informative data is day of week, carrier, sorry, year, quarter, month, day of month, origin, airport ID, destination, airport ID, CRS, arrival delay, cancel, diverted. So uh, just a minute. After dropping the column, you can run. You can run from this. Just we you can perform on Azure machine learning. Just click okay, run selector for, you can run select for specific step of Azure Machine Learning Studio. So okay, so select you will see on the side of bunch of summary statistics in this visualization. Select columns, so you can visualize this, what columns you select for your model and what columns you will drop. So 15 columns is left, so you need 15 columns to predict your model. So if I click it in, we can see that one of values is if you look at missing values, our missing values is this, like departure delay 15, like 0000. These are missing values. We can see a summary of all the missing value in the data set. So if you click on for example departure time book. So departure time book, it is completely filled in. Every value is there, same with this one right here. But if you want to go, if you have hundreds of columns or dozens of columns, even and thousands of columns, this would be a huge pain to click on every column them one at a time, and then to view the missing value counts themselves. Now luckily inside of Azure Machine Learning there is a module that runs all of that for you. So we go to the left side, search for something. Search for something called summarize data. Summarize data. So summarize so that there is a summarize data module which if you drag is here in here and connect it, so okay, you can go ahead and run it. So summarize data is that what column is missing value. You can summarize data, what column, what values are missing. So run this and check, visualize. You can go ahead and run it. And so I notice I'm connecting to summarize data module. So I'm making conscious note that this is not part of workflow. This is like a separate district. Summarize, remember, summarize data is not for our machine learning project. These are just no, just summarize our data, what data is useful, what data is missing. So this is like a separate descriptive text test. This is separate test of quality, if you will. So if I click try visualize, I will you can see basically the summary of all of my columns. So day of week, carrier, departure time, bulk, and departure delay. So what are my column names, and then what are the observation? These are the counts. Then I have a list of unique values. So notice days of week should have 7 days. If you look at the missing value, yeah, like this: missing value, day of week 0, carrier 0, bulk time 0. So a departure delay 3697 missing value, and departure delay 15 for 15 minutes, 3697, and arrival time and many others, 4047 are missing. So missing, if you look at the missing value count, and that's probably what we care about the most of this data set, which is how many missing value are there. So in departure delay and departure 15 is 3697 missing value, and that should be expected because departure 15 is derived from departure delay. So if the flight was late, shorter than 15-minute, departure delay becomes 1 instead of 0. And then we also look at what type they are. So in this case, the missing value is 2 features. So they are predictors. So but then in arrival delay has 417 4 no, 4 sorry 4717. Yeah, 4717 missing value. So this is also a problem because arrival delay 15 is also our response class, because response class is our main data, major data for predictions. So this is what we are going to try to predict. So remember we are going to use the past to predict the future, uh, where the past we know the result that brought about that past, this current, future. And so in this case we don't know the result of the past, so we can't learn from the past. So these rows will have to be dropped in a little bit. But while we are in here, so some more summary statistics we get in min and mix maximum. Just so clean and missing data. If clean and missing data, you can just drag and drop, and then drag and drop and connect the drop column from dropped columns, like select columns in dataset, and then visualize summary data. You can see the missing value. Okay. Okay. Arrival 15 minutes. So we just because we just clean missing data, select launch column selector, what column you select for drop all the values for, because missing values, when we are more missing values, so our model didn't predict or accurate predictions. So we just select what column you need to missing value clear. So arrival 15 is select, and then summarize our data, and you can see arrival 15, missing value in arrival 15 is 0. So after this we train our data and train a model. So check this. arrival delay 15 is our major data. So missing value count is, you can check before summarize data. It has 3000, I think 3397. Just yeah, 3397. So now we solve the problem, for solve this problem, missing data problem. So now we go towards casting and categorical data and split, and then split and train our model. So the next thing we have go to do we have go to split our data. So split our data. So and train set. So so the first thing we have getting to is categorical data. So why is categorical data need to be treated differently? So this is the major thing to be understand. So listen carefully. So numerics you can leave as so numerics data you can leave as numeric. Just make sure they are listed as numeric. But let's look at this data right here, where it is flight ID and state. But the whole backbone of machine learning is based upon math, algorithms, and things like that. And you can't do math on this category. You can do solve the problem. You can't divide, for example, Lahore by Karachi. Because Lahore and Karachi and any other state name, New York, any other Islamabad, any other city name is categorical data. Even you can't add Karachi to Lahore and get something else out. So the next backbone it can't do distance calculation. Distance calculation for principle of how a machine learning algorithm that something is similar and something is not similar to something else. So that normally has to be done a machine learning model to understand it, or for any computer to understand data in the form of categories. Is you have to create a separate column for each category. This is also called one hot encoding. This is also called binarization problem. So this is just called binarization. So this is what we are going to an example here. So notice if you are Lahore, if you are in Lahore, so you can't pick Karachi. And if you are Karachi, you can't be Islamabad, for example. This will be the same thing for male or and female, and this would be same thing for time zones, and this will be same thing for zip codes, city zip codes, like for 54,000 for Karachi and any other anything. That's category. So this is really prevalent in other data mining platforms such as Excel and things like that. But in Azure Machine Learning actually has a data type called categorical, which actually will do this tabularization transformation for you without you have to think about it. Uh, Okay, so what we have to do, we have to go into Azure Machine Learning and cast all of our categories into categorical data types so that our computer treats them properly. So let's go into our machine learning workspace and click on split data. So if you look under clean missing data, just a minute. Okay, clean missing data. Here's that's the last thing we have. We did you should have also had the summarized data from before 10 to 15 minutes. I told about the summarized data. So what I'm going to do, I'm going to right click on this split data, and you can and summarize data that called unique value count. So it basically tells you how many categories are it. Basically this column set how you can tell that something should be category. It's basically look into ratio compared to count versus how much there is. So you will notice that there is only 7 possible values and days of week out of almost 5 lakh rows. That tells you that this is probably a category because there are a few unique values count in regard. So you can click you can split you can split you can join from this casting categorical data and from with split data and split you can split mode split rows you select your splitting mode split rows or okay, just a minute, split rows. And so the main thing is fraction of rows. Just a minute. So, how do you tell if the model is good or not? Well, ideally, what you would do is, if the model can predict future values correctly, well, then it's good model. But the problem is that its job, right? Its job is to predict the future. So if you are going to evaluate on future data, and that at that point the model has failed this its job, because it's past its useful shelf. So if the model is predicting after the future happens, yeah, I think that's a bit useless. So what we have to do in the lab, in this machine learning studio lab, is we have to synthetically treat future world data, and we'll teach you some methodologies by which to do that. So the first methodology of many of by way, this is one of many methodology, and the first methodology I will teach you to train test split. So the idea is to start with 100% of your data, because in edit tasking check you visualize this data, you are 100% of our data. So this is where we have 4,99,000, I think, sorry, 50,000, 5 lakh 43,397 rows, or something like that. So the next thing if we need to do is we need to build two partitions, a training set and a testing set. In this case we are going to use the ratio of 70% split data and select the fraction of rows 0.7, like 70 divided by 100, so it means zero point 0.7. 0.7 is by default for training data. Training data set will randomly go into the test set. Sorry, I'm sorry. 70% of the data will randomly go into training set, and 30% of data will randomly go into testing set. And if some of, because we just write the training data set like 0.7, it means 0.3% is left. For 0.3% left for set by default set in testing set data, remaining the set data. So, and if some of you who know sampling, this is this sampling without replacement. So we are going to go ahead and put them into either two bags here. So the idea with the test set is we are going to take this data set and hide it away. We are going to pretend that it's future world data, and this is really important because it has a labels of the actuals, the ground truth, the actual labels. So that idea is if we build our model, we are going to take our model and we are going to build it using the 70% of training set, and the end of the day it's not going to see that 30%. So the model that the test set is a new world data to that model. The model has never been exposed to this data set, and the assumption is, so if this data, if this model that was built, if it built a generalization model that from the ground truth in the underlying data, and the idea if if it 0.3%, the testing data we didn't know about testing set, so we just write 0.7. We just know about 0.7 data, we didn't know about testing data. So in my mind, I think it's going to be I think of the 70% of training set, it's going to be sacrificed to produce this model, and it's going to learn from the past what resulted in the current labels being the way they are. And then that idea is once the model has been built. So And in our case, it's going to predict whether or not the flight will be late or not. It just so happened in the test that in the past we know if the flight was late or not. So we have basically we can build a comparison between predicted versus actual. So was this is this row right, like was this flight correctly predicted upon? We can go ahead and do that. We and If we aggregate um, all of the rights and we aggregate all the wrongs, eventually we can get some pretty good measures of performance out of this model. So before I go into what stratified split we have to look at something really quick. So what stratified split does is it keeps the ratio the same on both the test set and the training set. So if we look at arrival delay and arrival, uh, click on testing, training data visualize. So you can check the training set data, 35,000, 35,000, 3,078 rows. So our remaining test set data is on testing. You can visualize this, the testing data. Okay, so 15,000, 1,319 rows left for our testing data. So it kept the number of rows basically, or it kept the number of responses class labels in the same ratio as it was before. So let's also go ahead and look at our result data set 2, which is 30% of our data. So this is should be the remaining rows of data. So the next thing is to train our model. So okay, so now we train our model. Before train our model, you know about what the data is, what categorical data or regression problem. We finally get to take our data set, feed into our machine learning model, have the model iteratively learn by itself from historical data, or what are the kind of things that brought together the circumstances for the results. So basically whether or not a flight whether or not a flight will so we get to answer those questions soon. So let's go back to the data mining framework and remind ourselves where we are in the data mining framework. So we have a model ready data. So our all the data are in split between training set and testing set. First, what we are going to do is we are going to select an algorithm to train on. So select on, just click on our machine learning, click on machine learning and select on train, uh, and click on uh, just initialize model, sorry, click on initialize model and click what problems you can solve this, you can solve this. So understand your problem. So evaluate your problem. So it iterate further where we are in the methodology of the train test split. So where we are right now is we are right here. So we are going to build our model. It's not until predictions that we care about the test set. So 70% went on the train set and 30% went on test side. So we are going to pretend that we are going to pretend that it's tomorrow's sales data, tomorrow's flight data, for example, like this. So okay, our problem is on flight data. Okay, so the next thing we go to do is to train machine learning model in Azure Machine Learning Studio. You have to module called the train data. So you want to type a train model. Just click on train model. So train model, and you can drop it. Train model. Okay, the output nodes will tell you what it wants. On the left side means if it wants an end train model, and end train model means an algorithm, right? The model is the result of training, and then the model is the applicable form of the algorithm. The algorithm is just a blank set of instruction. Remember, algorithm is just a blank set of instruction on how to build that algorithm. The next thing is it wants in a data set, so it wants to learn from the past here. uh, so notice that we want to give it the training set the 70% of data. Now what we are going to do is we need to select an algorithm. So we if we go to Azure machine learning and look at algorithm, uh, algorithm, just click on evaluate into initialize model. So so go ahead and expand that initialize model. And now we get into this our this four families of machine learning models in anomaly detection, classification, clustering, and regression. So once you identify what your machine learning problem is, you will find out what your machine learning algorithm type you need. So there are four type of machine learning algorithm inside of Azure machine learning. So the first thing you need to figure out is this a supervised learning data set, meaning do you have labels meaning what is that you want to know from the past. In this case, I want to know it if a flight is going to be delayed in the past. Do I have that in my data set? Do I already have whether or not from the past this flight was delayed or not? Yes or no? So if it is yes, suppose like if I consider like it is yes, then it's supervised learning. I have labels to the past. I know the answer is in the past. I know the stock price in the past. So that's supervised learning. So the next thing you have to figure it out is that data type it is. So just because it is supervised learning, there is two type of supervised learning algorithm. There is classification type, there is aggregation type problem. If your feature, if the response, if your feature, if the response class is a label, if it is a category, it is a classification task. Okay, so you are trying to predict in this pixel like red, blue, or green. In this case we are not going to predict how many minutes will it be late by. We are going to predict whether or not it will be late at all past 15 minutes. So so that tells us its classification. Now regression, we have been if I want to predict how many minutes if it would be late. So so there was a column at the beginning that we dropped called I think arrival delay, and that was in minutes. So if we want to predict that later, yeah, that would be a regression prompt problem. So now that we know what type of algorithm we need, so next step is what we problem we need. So we go to and expand classification classification problem. So we go and classification task, and then the next thing I want you to know in how many classes are there in the response class. So notice that there are two classes: you are late or you are not late. Like 0 there, that is two class type algorithm. So basically we are stuck with these type of algorithm right here. Now if you have to super late, if you have to late super late, if you had that your friend in this flight case problem, we have two classification problem. And now this is the cool part. part that you hoping for a machine learning model. This kind of nice. This is of course of machine learning because you don't need to know what is them and they are working. But that now how a good practitioner does things. They are good probably understand a little bit before they start doing something with it. So first thing we are going to do, we are not going to really get into a difference between these algorithms. If you want to know difference, so equation most of it are non-parametric algorithms. So if we have a lot of categories, decision tree are really good at discerning a category apart from one another. So if we had lot of numerical data, like many other columns in numeric data, that would have been a different issue. So, but we have lots of category. Basically, there are three families of decision tree problems inside. Decision tree problems, two class problem, two class decision. You can expand it. Decision tree decisions for decision three problem, three families. So of decision tree problem inside. So our problem is two class problem. So two class problems, we are select just two class decision forest. So when you do the connect this here, just connect with a train model, because blank this blank I have already told you, without split data your model is nothing. Your model is didn't know what the data is. So I am going to connect this first, and then inside of this first there are what's called two new parameters. Model module is there. There should be some kind of launch button on right side, launch column selector. So this is time it says value required, column, and select the departure delay 15. We just because we trained just this column. So we are trying to predict is this a state predictor, because we didn't actually take your data set and predict on any column what type of carriers is at, what is the departure time, what is the departure place. So so you can go to predict and predict any of these functions. So in this case we know that we want to predict. So launch the column selector and click just a column, what column you want to predict. So because it is departure delay 15, because 15 means a 15-minute delay is a response class. So now that our training model know what to do. So now our model is what to do know about. So the next thing you want to do is you want to look at your algorithm model module. So the algorithm module for me is this case is the two class decision forest. Once you click on it, you will notice that there is just a minute. Yeah, there is a toolbar. We'll go ahead and click and check the binary decision fresh classifier. Uh, Okay, so resampling method and bagging, and create trainer model single parameter and number of decision tree. You can change as you required your decision tree. What iteration do you want? 1 to 100, 200. What accuracy do you want? 95, 90%, 80%. What you want? So depend on your decision tree trees 1 2 3 4 5 6 7 8 by I think it is 15. I just check you. It by default it is just 8, and maximum depth of your decision tree. Max depth is mean depth means I will explain the depth tree. I just a minute. Uh, what is depth tree? Okay, you can see you can see on my screen a paint. Depth tree means I will just told you about sorry, uh, size size. Okay, you can check depth of tree. Depth of tree means like this. You have multiple nodes and trees. You have multiple. Okay, so the depth is like this. Depth here. I'm 5 5 6 7 10 12 12 15. Depend on your accuracy what you want. So in this case, one the number of decision tree is 1, and maximum depth tree of decision tree is 5. Number of random split node is 128. Minimum number of samples per leaf node 34. It's up to you what you want and what the accuracy you want. So that humans can understand it. So what we are about to do here should not be used in production. I am doing this for educational purpose. The first thing I want to do is I want to reduce the number of trees down to 1. I want only to zoom in one tree right now. By the way, never deploy a single tree in production in the real world. You will regret it because you can increase the number 1 2 3 4 5 8 10 32 up to you. It's up to you. That's going to be a huge tree. It's might not even be able to look at. Even if I had a big screen monitor, if I want add the tree, I will change this to like 5 or 6. I am going to change it to 5, and then the next thing is number of random split is left is 128. Leave at alone for now. We will tune this parameters in a different scenario, different talk. The next thing you will talk at the minimum number of samples per leaf node. So basically this is the minimum number of observation I must have after a split. So once you have set all that, you go ahead and hit the run. Just hit the and run the button. So remember, we are ignoring the 30% for now. We just train our data 70%, and we didn't know about what our 30% data is. So we have to have enough representation in order for split to on that decision. And again, I want to state this is really dumped and simplistic model. Don't actually use this is production. Now this is so we can actually do we and what we are about to do now, which is right click and visualize on the model to train and visualize our model. It's got 5 I think it's got 10 just a minute. It's got 5, yeah, 5 depth model. So now remember earlier the default was 32. Can you imagine how basically hairy and that gets as it goes down? Now remember this is a very simplest tree, and also you never want to use a single tree in production. Remember please, you didn't do this tree for the model for just one number of decision tree. You just at least you use 8 10 15 what you want on your accuracy level. So but that was just showing for just educational purpose or just for this session. Can you see what the tree is doing, what the model is doing to your brand new data? So So after all the prediction in the Azure machine learning, you will publish to gallery and set up your web services, web service predict web services model recommend and publish on your web services which you publish on your Azure cloud computing. So and if you publish on this, to click on set up Azure web services, and if you want to get to for others to know your model, to predict your model, to publish for gallery. So this is the main difference. So this is all about my session. I hope you have learned a lot about Azure Machine Learning, how to start Azure Machine Learning and how to deploy. You can deploy it. Just click on your website, and if you publish on your web, because I didn't talk you about how to deploy your web. So you can deploy this model in your web or mobile app. Thank you. So just a minute. So thank you for listening. Thank you for listening patiently in and debug your brains. And in future, if you have any question from my side, you can contact me with me. My contact details is here. LinkedIn Mohammed Junaid Iqbal, and site my portfolio thejunaidikbal.com, and the email my hello@thejunaidikbal.com. Thank you again for joining me, and thank you so much, Adil, for giving me this opportunity and inviting me. Allah Hafiz. Adil, your voice is not, you are not audible. No, Adil, you are not audible right now. Check your, yes,
Am I audible right now?
yes, yes, yes.
Okay, just a minute. Let me set things up again. Okay, I'm audible, right, Junaid?
Yes, you are audible.
Uh, so thank you all for listening and learning a lot of great stuff from Junaid. I would like to thank Junaid for coming in this session and telling us and teaching us about Azure Machine Learning. Learning is the field that peak right now in the technological world, and there's a lot of work going in artificial intelligence, data science, machine learning. So this is one of the hot topics that is uh, that sorry, this is one of the hot topics that is being discussed in the technological fields, and a lot of research is going on these topics as well. So we will have our next event on okay um, okay, we have our next event on Sunday. The event the event is on quantum computing. So I hope to see you all there. Thank you. The quiz will be shared on the content link, so you can access the quiz and submit it, and the winners will receive the e-certificate. Thank you.